Okay, you guys, in this presentation, as I discussed in class, I was going to go through a couple examples for you that we didn't get to um, regarding fault current fundamentals, chapter 7 in your electrical safety related work practices. So just to kind of get started, if we just kind of draw a simple transformer one line diagram here, and this will be our overcurrent protection. And what we're looking at is calculating, oh, sorry, hit the wrong button. What we're looking at is calculating a fault that's going to occur right here. After the secondary of our transformer and before our primary overcurrent protective device. So in order to do that, we need to know a few things. We need to know a couple equations. We need to know what we're going to use is it's on page 137. It's called the simple method to determine worst case three-phase transformer secondary fault current. So for our transformer on our nameplate, we're going to be able to gather some information, which is usually given to us. So for this example, we're going to use, it'll be a 600 kilovolt amp transformer. It'll be 480 volts, three-phase, with a 5% impedance. For right now, just think of impedance as a resistance, similar to a DC circuit, but this is going to be an AC circuit, so we define it as impedance instead of resistance. So the formula to calculate this is current, or fault current, is equal to our transformer, oh, sorry about that box, times 100 divided by our percent impedance. Something we need to know is that on transformers, our percent impedance can vary from plus or minus 10%. So percent impedance can vary plus or minus 10% from the nameplate value given. And this 10% is considered a best case scenario, and our minus 10 is considered a worst case scenario with regard to fault current. And depending on which case we want, normally we're going to use the worst case scenario. That's going to tell us which multiplier to use. So for our best case, we would use a multiplier of 1.1. For our worst case, we'd use a multiplier of 0.9. And this is going to make more sense once we get into this equation. So in order to solve this equation here, we first need to know what our transformer, oh, I didn't put it in here. Let me rewrite this real quick. Transformer full load amps times 100. That's our equation. So we need to be able to, we need to find out what our transformer full load amps are. And that's a pretty simple equation to do that. So the equation for that, for our full load amps, so full load amps is equal to, let me rewrite this, current full load amps is equal to our kilovolt amps times 1000 divided by our voltage. That's going to be our line to line voltage times 1.732. When we enter these in the calculator, we need to make sure and put these in parentheses. So it's pretty simple. If we look at our information given, we're given 600 kilovolt amps times 1000 divided by our voltage, line to line voltage is 480 volts times 1.732 because it is a three-phase system. So if we calculate that out, making sure that we have everything in parentheses, 600 times 1000 divided by 480 times 1.732. That gives us a full load amps of 721.7. So now that we know that, we can easily punch in our information over here to calculate our fault current. So we know that our full load amps were 721.7 amps times 100 divided by, now we need to know that in this question, they're wanting to know the worst case scenario. So for that, we're just going to simply put in 0.9 times our percentage of impedance, which is 5%, and put that into our calculator. So parentheses 721.7 times 100 divided by parentheses 0.9 times 5. That gives us 16,037.7 amps. And remember, that's our fault current up here. So I sub FC, or fault current, is equal to 16,038 amps. So that's how you would solve that question. Now, it's important to realize that the fault current changes with a change in your impedance. So the lower the impedance, the higher your fault current's going to be. Or vice versa. So, looking at the same equation or problem, if we were to change this 5% impedance to, let's say, 3 without changing anything else. So this one we got to remember is at 5%. And our new fault current, we just simply punch that into our calculator. Would be 26,729.6 amps at 3% impedance. So you can see by just adjusting this impedance by just a little bit, lowering it, we have increased our fault current substantially from 16,000 to almost 27,000. Also keep in mind that with regard to your kilovolt amps, if your kilovolt amps increase, that's also going to increase your available fault current as well. So if we keep this at 3%, if we change this problem, let's say we want to go from 600 to 800. So now we have 800 kilovolt amps, which is going to change our full load amps. So instead of 600 here, we have 800. And if we calculate that out, this is going to change here. Our full load amps, we're still going to assume that we are at 3% impedance. So if we punch that into our calculator, 800 kilovolt amps times 1,000 divided by 480 volts times 1.732. That gives us full load amps for our transformer of 962.3 amps. So over here, we would type in 962. Oh, excuse me, my pen being difficult. 962.3. Put that into our calculators. We have 962.3 full load amps times 100 divided by 0.9 times 3. And that would equal 35,640.7 amps. And remember, so that would be 3% impedance, but at 800 kilovolt amps. So the important thing to remember is if sometimes in the field they can, if a transformer is faulty and they change it out, quite often they can replace it with a transformer that has the same kilovolt amps, but they are allowed to go ahead and step it up if they need to. And quite often that might be the case. And if they do that, that's going to increase your fault current by quite a bit. So I hope this helps. If you have any questions, be sure to get with me. Either the best way to contact me is via email, and I will write that down for you. If you have any other questions on your homework, my email is right here. And just be sure to email me any questions you have on the homework, and I'll be happy to get back with you and answer any questions you have as quick as I can. I apologize for not getting to you sooner on this. Um, there's a couple questions that are very similar to this towards the end of your homework. I think that this is probably going to answer the ones that I think were giving most students difficulty. Um, Once again, get a hold of me and best of luck.